Okay, here we go. So hopefully you've already tried these warm-ups because this is the kind of stuff you're expected to know on the quiz. So trying them and fixing them is better than just coming and getting the answers. So if that second option applies to you, please stop the video, go back, try all of these, and then come back and get the answers. Okay, so for number one, we're just literally asking you what these things mean. What does this little g in parentheses mean? Okay, so that means that the substance is a gas. Okay, B means aqueous. Lots of vowels in a row in that word, aqueous. We're also going to expect you to know that aqueous means dissolved in water, so if you want to add that, you can, but please just connect that word to water, okay? Dissolved in water is what aqueous means. C, what I'm really pointing at is this triangle up here. So the arrow, these two are reacting to form this stuff over here, but that triangle means that there's heat being applied to this reaction, okay? And then D is pointing towards that little S, so solid, okay? So solid zinc. All right. Number two, we've got solutions of iron 3 chloride and sodium hydroxide react to form an iron 3 hydroxide precipitate and a sodium chloride solution. We're translating that into a chemical equation. Remember that this Roman numeral right here means that that's a 3+ charge for the iron. Okay, and if we look at the chloride on the periodic table, it's -1. Okay, sodium hydroxide, sodium on the periodic table gives us a 1+ charge. Hydroxide, if we remember, is one of our polyatomics, and that's OH with a 1- charge. So we can use those charges to put everything together, okay? So iron 3 chloride is going to be FeCl3 because the 3 comes down from the charge in the iron and makes the ratio for the chloride, and the 1 comes down from the chloride, but we don't write ones, okay? It's a solution, so we're going to put AQ. Okay, the word and translates to a plus sign. Sodium hydroxide, again, solutions of iron 3 chloride and sodium hydroxide. So sodium hydroxide is also a solution. Sodium's a +1, hydroxide's a -1, so they already balance each other, and it's aqueous because it's a solution. React to form is going to be our arrow. Reacts to form, produces, creates, decomposes into, breaks down into, all of those kinds of things are going to be our arrows, okay? Iron 3 hydroxide precipitate. Okay, iron 3 hydroxide, Fe, parentheses, OH, parentheses, 3. We need 3 OHs to balance that +3 charge on the iron. And it's a precipitate, so it's a solid. Remember, a precipitate is a solid that forms when you mix two aqueous things. Okay, so that's our precipitate. And a sodium chloride solution, okay, NaCl, aqueous, sodium chloride 1:1, +1 -1. Okay, so A, translate it into a chemical equation. B, include the physical states, which we already did. C, balance the equation. Okay, I've got iron 1 on each side, chloride 3 over here, only 1 on the other side, so I'm going to put a 3 in front of that. Okay, and then sodium 1 over here and 3 over here, so I need to put a 3 in front of that. And then hydroxide 3 here, and we're done. Okay. And what type of reaction is this? This is a double replacement because we've got two compounds and they're trading partners. Okay, moving down here, so real-world application here. Catalytic converters are fitted to vehicles to reduce emissions related to incomplete combustion. Palladium catalyzes carbon monoxide and oxygen to form carbon dioxide. That's our first reaction. Additionally, rhodium catalyzes carbon monoxide and nitrogen dioxide to form carbon dioxide and nitrogen. Translate them into equations, include the catalysts, balance them, add physical states, classify. Okay, so let's look at that second sentence up here. Palladium catalyzes carbon monoxide and oxygen to form carbon dioxide. Carbon monoxide and oxygen are forming carbon dioxide. Carbon monoxide, which I hope that we know that that's a gas, okay? And oxygen, so and O2 gas, are going to form carbon dioxide, CO2 gas. Okay. Hopefully you can see by looking at this, we've got two things combining to make one, so that is going to be a synthesis. if you write combination, that's fine, but that's a synthesis reaction. But we can't forget our catalyst. Palladium is the catalyst. And if you look at the periodic table, palladium is Pd. Okay? All right. So next one is rhodium catalyzes carbon monoxide and nitrogen dioxide to form carbon dioxide and nitrogen. So we got carbon monoxide again, and plus nitrogen dioxide, NO2, all of these are gases, to form carbon dioxide and nitrogen. To form is our arrow, carbon dioxide and nitrogen. Don't forget, gens are diatomic. Okay? All right, and that one has rhodium as a catalyst, and rhodium, if we find that on the periodic table, is RH. Okay, and then reaction type. Ooh, all right, so we've got, this one is very much not a standard reaction type as far as the ones that we've looked at so far. But if we look at this, if we look at carbon monoxide, and over here it becomes carbon dioxide. Where did it get that extra oxygen from? Well, it stole it. It stole it from NO2. So carbon monoxide is stealing oxygen away from NO2 and kicking nitrogen out by itself. So we could call this a single replacement. It doesn't fit very nicely, but that is what I think it fits the best into. Now, if you made an argument for another type of reaction, I'd probably listen and you'd probably be totally fine and justified in it. But I'm looking at that as somebody stealing somebody's partner. And yes, this is already a couple, but it is still stealing a partner away from nitrogen, kicking it out by itself. I'm going to I'm going to pause for a second and balance it. So we've got this top one here. I have one carbon on each side, so that's good. But over here I have 3 oxygens, over there I have 2. But my oxygens are split up, okay? Whenever you have an odd versus an even, there's no way to make an even side have an odd number. So what we have to do is we have to make sure that this side has an even number of oxygens, and I have to make this guy right here even. So I'm going to put a 2 in front of my carbon monoxide. Now I have a total of 4 oxygens on this side, only 2 over here. So I need a 2 in front of CO2, and that also fixes my carbon. Okay. Similar situation down here. So right now carbon is balanced. Okay. Nitrogen is not. I need to double my nitrogen over here. I can start with that. We'll see. I might end up changing that later. Okay. And then I'm looking at oxygen. So here I have 4 oxygens. Here I only have 2. Oh, actually I have 5 on this side, only 2 on that side. You know what? I'm going to go ahead and do some algebra because this looks like it might be a little challenging to do with guess and check. So A, B, C, D for my substances. My carbon is going to be my first equation. I have A carbons on this side. I have C carbons on this side. So that means A has to equal C or my carbon will be out of balance. Okay? All right, oxygen is the tricky one. I have A plus 2B, and that has to equal 2C. Okay, otherwise my oxygen will not be balanced. And then finally nitrogen, I have B on this side. That has to equal 2D. Okay, set A equal to 1, and then I automatically get C equals 1. Okay. Now if I plug into this equation, 2 times C is 2 equals 1 plus 2B. Well, if I subtract that, well, let me write that out so that people who are following along can see it. 1 plus 2B equals 2. Subtract the 1 over, I'm going to get 2B equals 1. Okay, so B equals 1/2. Okay, so I've got 3 of my 4 variables here. And then B equals 2 times D, right? So 1/2 equals double D, right? So if we divide both sides by 2 there, we're going to get D equals 1/4. Or if you're a decimal person, this is going to be 0.5, this is going to be 0.25. Before I plug them back up into my equation, I need to make them all whole numbers. So I'm going to multiply to make my smallest fraction a whole number. So I'm multiplying everything by 4. So A becomes 4, B becomes half of 4, which is 2, C becomes 4, and D becomes 1 because a quarter of 4 is 1. So 4, 2, 4, 1 is my final answer there, and we're done.